Somewhere in this galaxy, right now, there is a small red star that has been burning since before the Earth existed and will still be burning 10 trillion years from now. It has used almost none of its fuel. Around stars like it, the universe will go on making worlds and life and possibly minds for a stretch of time so long that the entire history of everything so far is barely the opening minute of it. We tend to think of ourselves as latecomers. We assume the galaxy was full of ancient civilizations long before us, and we go looking for them in our past, in old stories and old stone. But the science points the other way. The universe is not old. It is young, almost newborn, and we have arrived close to the very start of it, which raises a question we almost never think to ask. If anyone is going to be the ancient ones, the impossibly early arrivals who were already here before the rest, what if that is us? Tonight, we are going to make the case that we are not the latecomers in this universe, but among its very first. By the end of this, you will understand why life could not have begun much earlier than it did, why the great majority of all the worlds that will ever exist have not been born yet, and why the age of life is barely starting, with trillions of years of it still ahead. And you will understand why that single fact that we are early quietly turns the oldest idea about ancient aliens all the way around and points it back at us. Start with the number we think makes the universe old: 13.8 billion years. That is the time since the beginning, and it is genuinely hard to hold in the mind, long enough that the Earth at 4.5 billion years has existed for only the last third of it. So it feels like a great age, like the universe is a thing well into its life. It is not. By the only measure that matters, the lifetime of the stars themselves, the universe has barely started, and we are standing right at the front of it. Here is the measure. Astronomers map the deep future of the universe in long stretches they call eras, the age of shining stars. It is the stretch in which the universe is full of stars burning hydrogen, the era of galaxies and starlight, and worlds warmed by suns. It began a few 100 million years after the beginning, when the first stars lit, and it does not end for a very long time. On the best current reckoning, it runs until somewhere around 100 trillion years from now, when the last stars finish forming and the final small ones gutter out. 100 trillion years. Set the 13.8 billion that have passed against that, and the part of the age of starlight that is already over is not even 1,000th of it. We are not in the middle of the story, we are in the first sentence. It helps to feel that against something you already carry a sense of. If the entire age of shining stars, every star the universe will ever make from the first to the last, was squeezed down into a single year, then the whole of cosmic history so far, the beginning, the first galaxies, the birth of the sun, the 4 billion years it took life on Earth to crawl from single cells to us, all of it would fit inside the first morning of the 1st of January. The sun would not even have formed until the small hours of that first day. Everything you think of as ancient, the dinosaurs, the age of the Earth, the oldest light we can see, would be over before the first dawn of that year had properly broken, and the other 364 days would still be ahead, unwritten, almost entirely empty of everything that has happened so far. That is the real shape of where we are. Not late, not even early in the casual sense. We are in the opening minutes of an age that runs for trillions of years, and almost the entire thing is still to come. Look at our own star against that, because the sun gives a false sense of the timescale. The sun has been burning for 4.5 billion years, and has roughly 5 billion years left before it swells, sheds its outer layers, and collapses into a slowly cooling cinder. 10 billion years, give or take, from birth to death. That sounds enormous, and by the standard of a human life it is beyond comprehension. But the sun is a bright, fast living star, and bright, fast living stars are the ones that die young. They burn hot, they burn through their fuel quickly, and they are gone. The sun is not a marker of how long the age of stars lasts. It is one of the early casualties of it. Because the stars that set the real length of the stelliferous era are not stars like the sun at all. They are the small, dim red ones, and we are coming to them. The point for now is only this: the brightest, most familiar kind of star, the kind we orbit, will have lived and died many times over before the age of starlight is even half spent. When the sun is long dead and cold, the universe will still be making stars and warming worlds, and it will keep doing so for a length of time that makes the sun's entire existence look like a single brief flash near the beginning. The sun is not the clock, it is a spark near the start of a fire that burns for trillions of years. So the universe is not an old thing winding down, it is a young thing barely lit. And once you take that seriously, once you really hold the idea that 13.8 billion years is the opening and not the bulk, a lot of comfortable assumptions start to wobble. We assume there has already been plenty of time for everything to happen, that whatever the universe was going to produce, it has mostly produced by now. That assumption is built into the way we think of ancient aliens, civilizations that rose and fell long before us in a universe that had all the time in the world to make them. But if the universe has only just begun, then there has not been plenty of time. There has been almost no time at all, by the standards of what is coming. And a universe that has only just begun has a very different relationship to the worlds and the life it will eventually hold. I want to be honest about what we can and cannot stand on here, because the far future is not something anyone has watched. Everything past the present is calculation. The laws of physics we have now run forward across spans no one will ever see confirmed. We are confident the small stars burn for trillions of years because we understand how they fuse hydrogen and how slowly they do it. We are confident the age of starlight ends because the gas that makes stars is finite and is slowly being used up. But these are projections, and projections rest on the assumption that the rules do not change over timescales vastly longer than the universe has so far existed. That assumption is reasonable. It is how all of physics works. It is not the same as having been there to look. So when I say the universe is barely begun, understand that it is a statement about what the physics predicts. Run forward into a darkness we infer, rather than observe. It is worth seeing how small the age of stars is, even against the rest of the future, because that puts the present in its place even more sharply. The stelliferous era, the whole 100 trillion years of starlight, is itself only one stretch of the universe to come, and not the longest one. After the last stars gutter out, the universe enters what astronomers call the degenerate era, a stretch dominated by cooling stellar corpses, the white dwarfs and neutron stars left behind. And that era lasts not for trillions of years, but for a length of time written with dozens of zeros. After that, an age belonging to black holes, slowly bleeding away their mass over spans that make even the degenerate era look brief. The luminous part of the universe, the only part with starlight to warm a world, is a thin, bright band near the very beginning of a future that runs on, dark and cold, almost without end. We are not just early in the age of stars, we are early in the one short, bright, life-friendly age of a universe that spends almost all of its existence in the dark afterward. Try holding the present against that, the way you would hold a single day against a long life, because the mind needs something to grip. The universe has been around for 13.8 billion years, and that is the entire stretch we ever talk about, the whole span that contains the beginning, the first galaxies, the birth and death of countless stars, the forming of the Earth, and the slow climb of life to this moment. Every event you have ever heard described as ancient happened inside that one span, and that span is less than 1,000th of just the age of starlight still to come. Never mind the vastly longer dark eras after it. The oldest thing you can name, the oldest light, the oldest rock, the first life, all of it is crowded into a sliver at the very front. There simply has not been much time yet. It feels like there has, because 13.8 billion years is so far beyond a human life that it reads as forever. But against the clock the universe actually runs on, it is the first tick. We mistake the start of the story for most of it, because the start is all that has happened so far. And the sun sits inside that opening sliver as one of the early, short-lived bright stars, which is worth dwelling on because it quietly corrects how we think of the lifespan of everything. A star like the sun shines for roughly 10 billion years from birth to death, and then it is finished, swelling into a red giant that scorches its inner worlds before shedding its outer layers and settling into a slowly cooling ember. 10 billion years feels endless, and against a human life it is. But it is short for a star. The sun burns bright because it burns hard, fusing its hydrogen quickly to hold itself up against its own gravity, and that bright hard burning is exactly what uses the fuel up fast. The brilliant stars, the ones that light the sky we know, are the ones that die soonest. By the time the universe reaches its long afternoon, every star like the sun will be long dead, their era a brief early flash in the deep past. The stars that endure, that carry the age of life across its trillions of years, are the dim ones we barely notice, and they have scarcely begun. So the sun is not a measure of how long the universe stays lit. It is a reminder of how quickly the bright early stars come and go, and of how near the front of things we are, warming ourselves at one of them. There is another sign of the universe's youth, one you can almost see, and it is that the universe is still visibly building itself. Galaxies are still colliding and merging into larger ones all across the sky in slow-motion crashes that take hundreds of millions of years to play out. Our own galaxy is on a collision course with its large neighbour, and the two will eventually merge into a single greater one, an event still billions of years in the future. Fresh stars are still igniting in the spiral arms, lit out of collapsing clouds of gas and dust, in nurseries that glow across the galaxy. The universe is not a finished thing settling into old age. It is still in the middle of assembling its largest structures, still actively making stars, still rearranging itself on the grandest scale. That is not what a mature, late-stage universe looks like. It is what the early chapters of one look like. A place still under construction, with most of its buildings still ahead of it. And we are here for that early construction, watching a universe that has not nearly finished becoming whatever it is going to be. Part of why the universe feels old to us is that we have nothing to measure it against, no reference for deep time at all. The whole of recorded human history runs to a few thousand years. Everything we have ever written down, every civilization that has risen and fallen on this planet, fits inside about 10,000 years, and even the existence of our species is only a couple 100,000. Against that, 13.8 billion years is simply incomprehensible, so the mind files it under forever and stops. But the universe does not run on the human scale, it runs on the stellar one, and on that scale 13.8 billion years is brief. The dim stars that will define the age of life measure their lives in trillions of years, and the dark eras after them in spans with dozens of zeros. We call the present moment old because it dwarfs us, and it does. The mistake is in thinking that because it dwarfs us, it must also dwarf the universe. It does not. By the universe's own clock, set by its longest-lived stars and its slowest processes, this is still the first hour, and we are early risers in it. Still, the prediction is about as solid as cosmology gets, and it points one way. The age of stars is long, longer than almost anyone's intuition allows, and we are at the very front of it, which raises the question this whole video circles. If the universe is barely begun, and almost all of its time is still ahead, then where does that put the Earth, not in space, but in time? Among all the worlds that will ever exist, did we arrive in the middle of the crowd, or somewhere stranger? When the Earth formed, about 4.5 billion years ago, only about 8% of the habitable worlds that will ever exist had been born yet. The other 92% were still ahead. That single fact, more than any other, is what turns this from a thought experiment into something the numbers actually force. Earth is not a middle child in the family of worlds. It is one of the firstborn, and almost all of its siblings are still to come. That figure comes from putting two things together. The first is the star formation history of the universe, which we can read directly by looking out at galaxies at different distances, and therefore at different ages, all the way back toward the beginning. Looking far out is looking far back, so the light arriving from the most distant galaxies shows the universe as a young place busy making stars, and the nearer galaxies show it slowing down. From that we can chart how the rate of star birth has risen and fallen across cosmic time. The second piece is what we have learned about how planets form around stars, how common small rocky worlds are, and what kind of stars they tend to circle. Lay the planet making over the star making, run it forward as well as backward, and you get a history and a forecast of habitable worlds across the whole life of the universe. When two researchers did exactly that, the answer that fell out was stark. At the moment the Earth appeared, the universe had made only a small fraction of the rocky, potentially life-bearing worlds it is going to make. Most of them have not formed yet. Sit with the size of that majority. 92% of the habitable worlds that will ever exist are still in the future. They are not out there now, waiting to be found. The gas that will become them is still drifting in galaxies that have not yet gotten around to collapsing it into stars and planets. Most of those worlds will form in the far future, in the dwarf galaxies and the great clusters that still hold reserves of unused gas, long after our own galaxy has largely run dry. The Earth did not arrive into a universe already crowded with worlds. It arrived into one that had barely started building them. And there are already a great many. Just within the part of the universe we can see, the count of Earth-like worlds runs to something on the order of 10 to the power of 20. That is a 1 with 20 zeros after it, a number of worlds so large that if you tried to visit one per second, you would not finish in the entire current age of the universe, not even close. And that enormous number is the 8%. It is the small early fraction. The universe is on track to make many times more than it already has, the great bulk of them in an era we will never see. This is the part that should reframe how you hear the phrase ancient aliens. The whole idea of elder civilizations rests on a hidden assumption that worlds like ours have been forming for a very long time, that there was a long stretch of cosmic history before us in which countless Earths came and went, plenty of time and plenty of places for the old ones to have risen. The planet-making history says the opposite. There was not a long stretch of Earths before us. We came near the front of the line. The worlds that could have hosted civilizations older than ours are, by the numbers, rare, because most worlds that will ever exist have not been built yet. The deep past of the universe is not crowded with planets. It is comparatively empty of them, and getting emptier the further back you look, until you reach a time when there were essentially no worlds like ours at all. I want to be careful and honest about how firm this is, because it is a projection and not a measurement. The 8% figure comes from a model, and the model assumes that star formation keeps going in the way our current model predicts, that the gas keeps cooling and collapsing into new stars and worlds for a long time to come. The exact percentage depends on those assumptions and on how common habitable worlds really are, which is still uncertain at the level of a factor of a few. If you change the inputs, the number moves. It might be 85% yet to come, it might be 95%. What does not move across any reasonable version of the model is the direction of the answer. By every accounting we have, the Earth formed early, the majority of habitable worlds lie in the future, and we are nearer the beginning of planet making than the middle of it. The precise figure is open, the earliness is not. There is something almost vertiginous in that once it lands. We are used to thinking of the Earth as ordinary, an average rock around an average star, and in many ways it is. But in time, in its position along the whole history of when worlds exist, it is not average at all. It is unusually, strikingly early. We tend to assume we showed up to a party already in full swing, with the interesting guests long since arrived, and half of them already gone. The truth looks more like we are among the first few to walk through the door, into a place that will slowly fill over a span of time so long we cannot stay to see it happen. The way we know Earth came early is not a guess. It is read directly off the sky, because looking far out into space is looking far back into time. The light from a galaxy 1 billion light years away left it 1 billion years ago, so it shows that galaxy as it was then, young and busy. Light from farther still shows the universe younger again. By gathering that light across a great range of distances, astronomers have charted how fast the universe was building stars at every point in its history, and the shape of that history is clear. Star birth rose to a furious peak when the universe was only a few billion years old, a time so productive it is sometimes called the high noon of cosmic star formation, and it has been declining ever since. We are well down the far side of that peak now, on the long, slow slope of a universe making stars more slowly than it once did. But declining is not the same as finished. There is still an enormous reserve of gas out there that has never been turned into stars, drifting in galaxies that have not yet collapsed it, and that gas is the raw material of all the worlds still to come. Most of those unborn worlds will not form here, in a galaxy like ours, but elsewhere, and where they form tells you something about how early we are. Our own galaxy has already spent much of its store of star-making gas. It is past its most fertile years, building new stars at a fraction of the rate it managed when it was young. The great nurseries of the future lie in places that still hold their gas in reserve, the small dwarf galaxies that have been slow to use theirs, and the enormous clusters of galaxies where deep reservoirs of gas still wait to cool and collapse. It is in those places, over the next many billions and then trillions of years, that the bulk of all habitable worlds will finally be born. The Earth did not form in that great wave. It formed before it, in an early galaxy that got going fast, ahead of the crowd. So we are not only early in time, we formed in one of the places that got an early start, which makes us early twice over, a world that beat both the clock and most of its neighbours to existence. The sheer count of worlds is hard to keep in the head, and it cuts against the feeling that an early arrival must mean a lonely or empty universe. Within the part of the universe we can see, the rocky, potentially life-bearing worlds already number something on the order of 10 to the power of 20. That is not a count of stars, it is a count of Earth-like planets, and it is already so large that it defeats any attempt to feel it. And every one of those worlds is the early 8%, the small first installment. The universe is set to make many times that number again before it is done, the overwhelming majority of them in the deep future. So being early does not mean being one of only a handful. It means being one of an enormous early population in a universe that will go on to make a far more enormous late one. The crowd is not small. It is simply mostly still ahead of us, unborn, in galaxies that have not yet made their stars. There is a real advantage hidden in having come this early, and it is one the late worlds will never have, though we will get to the full force of it later. Because we arrived while the universe is young, the sky above us is still crowded. We can look out and count hundreds of billions of other galaxies stacked back almost to the beginning, and from their light we can read the whole history of how the universe grew. A world that forms in the deep future, after most of those galaxies have been carried out of view, will look up into a far emptier sky and have almost nothing to read. So being early is not only a matter of being near the front of the line of worlds, it is a matter of being born while there is still a view, while the universe still openly displays its own past and its own scale. The early worlds, ours among them, get the full view. The late ones get a fragment and never know it is only a fragment. That difference will matter enormously by the end of this, and it grows directly out of the simple fact that we came near the start. Here is a thought that sharpens just how early we are. The great majority of the worlds that will ever hold life do not orbit stars that exist yet. The stars themselves, the dim, enduring red ones around which most future life will gather, are for the most part still unborn, still locked up as cold gas in galaxies that have not gotten around to making them. So when we say 9 in 10 habitable worlds are still to come, we are not just talking about empty planets waiting to form around existing stars. We are talking about worlds around suns that have not yet been lit, in systems that do not yet exist, in galaxies still holding their gas in reserve. The company we wonder about, the other minds the universe might hold, are not only unborn, most of the stars they will live beside have not even begun to shine. That is how near the front of things we are. Not only before the crowd, but before most of the fires the crowd will warm itself by have been kindled at all. There is a clean way to feel the asymmetry of our position. Look backward in time from this moment and the worlds thin out fast, fewer and fewer the further back you go, until you reach an era with essentially none at all. Look forward and they multiply, more and more, for billions and then trillions of years, until the great bulk of all habitable worlds that will ever exist have finally formed. We are sitting on the hinge between those two, with almost nothing behind us and almost everything ahead. That is not the position of a typical world. A typical world, drawn from the whole span of cosmic time, sits far out in that crowded future, with countless others behind it. We have almost none behind us. Whatever else is true, we are not in the middle of the line of worlds. We are up near its very head, where the line has barely started to form, looking back at an almost empty past and forward at a future that will fill long after we are gone. Which raises the obvious question, the one that has to come next. If Earth is early, why? Why could a world like ours not have formed billions of years sooner, right back near the beginning, when the universe was fresh? What was missing, out there in the young universe, that had to be built before a planet like this one, and the life on it, was even possible? The young universe could not have made the Earth, because the Earth is built out of materials that did not yet exist. Go back far enough, and there is no rock anywhere, no iron, no carbon, no oxygen, nothing a planet like this one, or a body like yours, could be made from. There is almost nothing but the two lightest elements, hydrogen and helium, the gases the universe came out of the beginning with. Everything heavier had to be manufactured later, inside stars, and that manufacturing took time. This is the flaw under the start of life, and it is the reason we could not have come much sooner than we did. Think about what your own body is made of. The carbon in every cell, the oxygen in the water that fills you, the calcium in bone, the iron in blood, the phosphorus, the nitrogen. None of those existed in the early universe. They were all forged in the cores of stars, where the crushing heat and pressure fused light elements into heavier ones, and they were scattered into space only when those stars died, blown out in stellar winds or flung across the dark in the explosion of a supernova. The matter you were made of was cooked in stars that died before the sun was born. So was the matter of the Earth itself, its rocky mantle, its iron core, the whole solid world under your feet. To build a planet like this, the universe first had to run generations of stars, let them die, and seed the dark with their ashes. In the beginning there was none of that. The first stars formed perhaps 1 to 200 million years after the beginning, out of nothing but hydrogen and helium, and they were unlike any star that shines today. With no heavy elements to change how they burned, they grew enormous, blue-white and ferociously bright, many times the mass of the sun, and they tore through their fuel and died fast, in millions of years rather than billions. But in living and dying they did the essential thing. They fused the first heavier elements in their cores and then, in their death throes, threw them out into the surrounding gas. The first carbon, the first oxygen, the first iron. Each generation of stars enriched the clouds a little more, and the next generation formed from gas that carried the ashes of the last. And slowly, over billions of years, the raw material for rocky worlds and for life accumulated. That is why there is a delay built into the universe before anything like us is possible. It is not that life was unlikely early on. It is that the ingredients did not exist yet, and there was no shortcut to making them. You cannot have a rocky planet in a universe that has not yet manufactured rock. You cannot have water-based chemistry before there is oxygen, and there is no oxygen until stars have made it and died to release it. The enrichment of the universe with heavy elements is a slow process that runs on the lifetimes and deaths of stars, and it had to reach a certain level before a world like the Earth could even form, let alone grow life. By the time it did, several billion years of cosmic history had already gone by. The floor was reached only a few billion years before the sun lit, which is to say, only a little while before us. This cuts directly against the oldest version of the ancient aliens idea, the one where advanced beings have been around almost since the dawn of the universe, ancient beyond anything we can conceive. They could not have been. For the first stretch of cosmic history, there were no worlds for them to live on, and no atoms heavy enough to build them from. The deep past was not a place where elder civilizations had endless time to rise. It was a place that lacked the basic materials for any civilization at all. The universe had to spend billions of years just making the stuff that life requires before life could get its first real chance. And that chance came not long before we took it. I should mark the edge of what is actually known here, because there is genuine uncertainty in exactly where the floor sits. We do not know the precise amount of heavy elements a system needs before it can make rocky worlds and living chemistry. It may be that life can get started with less enrichment than we assume, around stars poorer in heavy elements than the sun, which would push the floor a little earlier and make the first possible life a little older than this account suggests. There are old stars out there, formed when the universe was young and still metal poor, that do turn out to have rocky worlds, which hints the threshold might be lower than once thought. So the exact start line is not nailed down. What is not in doubt is that there is a start line, that the very early universe was too chemically barren for anything like us, and that the enrichment took billions of years. We are not far past that line. We came near the earliest moment life of our kind could plausibly have appeared at all. The first stars deserve a closer look, because they are the machines that made everything we are out of almost nothing. They formed out of clouds of pure hydrogen and helium, and with no heavier elements mixed in to help the gas shed its heat and break into smaller pieces, the clouds collapsed into enormous single stars, far more massive than the sun, some of them many tens or hundreds of times its mass. They blazed an intense blue-white, far hotter than our star, and they lived fast and violently. A star like that burns through its fuel in only a few million years, a flicker by cosmic standards, and then it dies, often in a tremendous explosion that for a moment outshines an entire galaxy. In that death it does the thing the universe needed, the fusion in its core, and the searing instant of its explosion, forge heavier elements and fling them out into the surrounding gas. The first carbon, the first oxygen, the first iron, scattered into the dark by stars that lived briefly and died hard, seeding the clouds from which the next generation would form. Each later generation of stars then formed from gas, a little richer than the last, and built on what the dead ones left. The cycle is slow, and it is patient. A generation of stars lives and dies, enriching the gas with the elements made in their cores. New stars condense from that enriched gas, and around some of them for the first time, there is enough heavy material to gather into rocky worlds rather than just more balls of hydrogen. Those stars live and die in turn, enriching the gas further, Over billions of years, the heavy element content of the galaxy climbs, slowly, from essentially nothing toward the level the Sun and the Earth would eventually need. There was no way to rush it. The elements that make a planet and a body can only be made inside stars, and stars take time to live and die. So the long delay before the Earth was even possible is not a quirk. It is the unavoidable cost of having to build the raw materials of worlds and life, one stellar generation at a time. This is the part that lands against human time, if you let it. Every heavy atom in you is older than the Sun, made in a star that died before our star was born, and carried through space to be gathered into this world and eventually into you. The iron in your blood was forged in the heart of a dying star and thrown out into the dark to drift for ages before it ever reached here. That is not a metaphor. It is the literal history of the matter you are made of. And it could not have happened quickly. The universe had to run for billions of years, making and destroying stars, before there was enough of that forged material gathered in one place to build a world like the Earth and the chemistry that became us. We are not just early arrivals. We are early arrivals made of the ashes of the few generations of stars that managed to live and die before us, in a universe that had barely had time to make the stuff we are built from. It is worth naming where the pieces of you were actually made, because it scatters your origins across the depths of different kinds of stars. The carbon that forms the backbone of every molecule in you was forged mostly in the cores of dying stars of moderate size, dredged up and shed gently into space as those stars swelled and threw off their outer layers near the end. Much of the oxygen you breathe and drink was made in heavier stars and blasted out when they exploded. The iron in your blood and in the Earth's core came in large parts from those same titanic explosions and from the collisions of the dense burnt-out cores stars leave behind. Heavier things still, the trace metals scattered through your body and your world, were flung out in the most violent events the universe stages. So you are not made from one source. You are assembled from the ash of many different stellar deaths, gathered over billions of years into one cloud, which collapsed into the Sun and its worlds, and eventually into you. None of that was quick, and none of it could have happened in a young universe that had not yet run enough stars to their ends. The slowness of it is the reason we are early. The universe had only just finished making enough of us to build us from. The very first stars left almost no trace we can point to, which is its own kind of evidence for how early everything still is. Those original stars, formed from pure hydrogen and helium, were so massive and so short-lived that they died long ago, and being made of the lightest elements only, they seeded the first heavier ones and then were gone. We have never directly seen one. We infer them from the chemistry they left behind, and from the glow of the early universe. But we can still find their grandchildren, very old stars formed when the universe was young and still poor in heavy elements, stars almost as old as the galaxy itself, scattered through it like relics. They are metal-starved, made of gas that had been enriched only a little, and they tell us how slowly the building up of heavy elements went in those first ages. Reading them is like reading the early pages of the universe's own record, and what the record says is plain. For a long stretch near the beginning, the material for worlds and life simply was not there yet, and it accumulated only gradually, one generation of dying stars at a time, until at last there was enough to make a world like this one. So there is a beginning to the age of life, and we are close behind it. That tells us how far back it begins. It says nothing yet about how far forward it runs, and that is the other half of the story, the half that decides everything. If the age of life had a floor a few billion years before us, and a ceiling not long after us, then we might sit in the middle of a short, bright span, ordinary after all. But if it opens just before us, and then runs on for an almost unimaginable length of time, then our position changes completely. So how long does the age of life actually last? How far ahead does it run? The age of life does not run for billions of years. It runs for trillions, and almost the entire span of it is still ahead of us, because the stars that will host most of that life are the ones that have barely started to burn. To see why, you have to look away from stars like the Sun and toward the small dim red ones that are, by an overwhelming margin, the most common stars in the universe. They are called red dwarfs, and they are nothing like our star. A typical one has perhaps a tenth or a fifth of the Sun's mass, glows a deep red, and puts out a tiny fraction of the Sun's light, sometimes less than 1,000th of it. They are so faint that not a single one is visible to the naked eye from Earth, despite the fact that they outnumber every other kind of star combined. The nearest star to the Sun, Proxima Centauri, is one of them, and the thing that matters about them tonight is how they burn. A red dwarf sips its fuel. It fuses hydrogen so slowly and mixes its interior so thoroughly that it can keep going far longer than any larger star, not for billions of years, but for trillions. A small one, around a tenth of the Sun's mass, can burn steadily for something like 10 to 12 trillion years. Hold that number against the age of the universe. The universe is 13.8 billion years old. A red dwarf can burn for 10 trillion. That means the entire history of the universe so far, everything that has ever happened, is less than a single thousandth of the lifetime of one of these stars. Put another way, not one red dwarf that has ever formed anywhere in the universe has yet reached the end of its life. There has not been time. Every red dwarf that has ever existed is still burning, every one of them still in its infancy, with the overwhelming majority of its life ahead of it. The universe is far too young to have lost even one of its longest-lived stars. Now lay the long lives of those stars over the question of when life is most likely. Because life needs time. It took something like 4 billion years on the Earth for life to go from its first simple beginnings to anything you would call complex, and longer still to reach anything that could look up and ask these questions. Long stretches of stable warmth are exactly what biology seems to need, and a red dwarf offers stretches of stable warmth beyond anything a star like the Sun can give, not billions of years but trillions, a steady low fire that does not gutter or swell for almost the entire life of the universe to come. When the probability of life is worked out across all of cosmic time, weighing how many stars of each kind there are and how long each provides a home, the answer does not peak now. One careful calculation of this by the astronomer Abraham Loeb and his colleagues found the peak lies some 10 trillion years in the future, around exactly these small, patient, long-burning stars. Not now, not near now, 10 trillion years from now. That is the long afternoon of the universe, and we are nowhere near it. We are in the first thin light of the morning, around a bright, fast star that will be dead long before the real day begins. The age in which life is most abundant, most at home, most likely to be looking up and wondering, is not behind us and not around us. It is an almost unimaginable distance ahead, in a universe lit mostly by dim red stars that have, as yet, barely begun. I have to be straight with you about the large uncertainty sitting under this, because it is real and it could change the account. The whole idea that life peaks in the far future rests on red dwarfs actually being able to host it, and that is genuinely unsettled. These small stars are calm in their old age, but they are violent in their youth, throwing out enormous flares that could strip the air and water off a nearby world. Their habitable zones are tucked in close, so close that a planet there may end up with one face locked permanently toward the star and one toward the dark. And during the star's long, bright early phase before it settles, a world in that zone may be baked hard enough to lose its oceans entirely. If those problems prove fatal, if worlds around red dwarfs turn out to be barren, then the far future is not the great age of life after all, and we might be far more ordinary in our timing than this account suggests. The astronomer who ran those numbers said as much, that the result holds only if life around small stars is not ruled out. So this is the live edge of it. The case that we are early is strong, but it leans on a question about those red stars that we have not yet answered. What makes a red dwarf last so long is the unhurried way it burns, and the physics of it is worth stating plainly because it is the engine of the whole far future. A star holds itself up against its own gravity by the heat of fusion in its core. A massive bright star needs to burn furiously to hold up all that weight, and so it tears through its fuel. A red dwarf, with only a tenth or a fifth of the sun's mass, has far less weight to support, so it can fuse its hydrogen at a slow, miserly rate and still hold itself together. On top of that, a small red dwarf churns its whole interior over by convection, slowly mixing fresh hydrogen down into the core instead of leaving spent fuel stranded there, so it can burn very nearly all of its fuel rather than the fraction a star like the Sun manages. Slow burning and near total fuel use together stretch its life to something like 10 or 12 trillion years. It is the most patient kind of fire the universe knows how to make. And these small patient stars are not rare oddities. They are the standard, the most common star by far. The nearest star to the Sun is one of them, Proxima Centauri, a dim red speck too faint to see without a telescope, and it has a world in its habitable zone. Barnard's star, another near neighbour, is the same kind. The TRAPPIST system, with its crowd of small rocky worlds packed close around a tiny cool star, is the same kind again. 3 out of every 4 stars in the galaxy are red dwarfs, which means the typical world in the universe does not orbit a star like the Sun. It orbits one of these dim red embers in a tight little habitable zone close in, where the star will go on burning steadily, not for billions of years, but for trillions. If life can take hold around stars like these, then the homes of almost all the life the universe will ever hold are exactly these small, enduring fires, and they have barely been lit. Set the habitable lifetimes side by side, and the gap is the whole story. A world around a star like the Sun gets, at best, a stretch of a handful of billion years in which conditions stay friendly to life, and ours is already well into that stretch, with perhaps a billion or 2 of comfortable years left before the slowly brightening Sun cooks the Earth and ends it. That is the generous allowance a bright, fast star gives. A world around a small red star gets something almost incomparably longer, a steady warmth held nearly constant not for billions of years but for trillions, because the star itself barely changes across that whole span. Now lay against both of those the one time scale we have actually measured, the time it took life here to get anywhere. On Earth it took something like 4 billion years to go from the first simple living things to anything that could look up and ask a question. Life is slow. It needs long, stable stretches of warmth to climb from simple to complex. A star like the Sun barely gives enough, and then it is gone. A red dwarf gives 1,000 times more. If life needs time, and everything about its history here says it does, then the enduring red stars are not the marginal homes for it. They are the best homes there will ever be, and they are almost all still ahead. Set yourself down on a world in the habitable zone of one of these red stars, and the physical reality is unlike anything here, but it is steady, and steadiness is what life seems to need. Because the star is so dim, the world has to sit close in to stay warm, and a world that close tends to become locked, turning the same face to its star forever, the way the moon keeps one face to the Earth. So one side lives in permanent red daylight, the star hanging motionless in the sky, neither rising nor setting, a deep red disk that never moves. The other side faces permanent night, turned forever to the dark and the distant stars. Between them runs a band of perpetual twilight, a ring of endless evenings circling the whole world, where the warmth of the day side meets the cold of the night. It is a strange arrangement, but it can be stable, and it can stay stable, not for billions of years, but for trillions. The red star overhead holding nearly constant across a span of time that beggars the lifespan of our own sun. If life can hold on through such a world's violent youth, then what waits for it afterward is the longest, calmest afternoon any world will ever be given. The reason this is not a settled victory, and the place I have to be most careful, is that red dwarfs are calm only in their long maturity, not in their youth. When a red dwarf is young, it is restless and violent, throwing out flares far larger in proportion than anything the sun produces, blasting any nearby world with radiation that could strip away its air and split apart its water. And because the habitable zone sits so close in, a world there feels all of that at point-blank range, and may be locked with one face always to the star, and one always to the dark. Worse, a red dwarf is brighter in its youth than in its long settled age, so a world in the comfortable zone of the mature star may spend its first hundreds of millions of years baked hot enough to boil off its oceans entirely, left dry before life ever gets a chance. If those early trials prove fatal across the board, then the long afternoon may be far less fertile than the raw lifespans suggest, and the whole case for life peaking in the deep future weakens. This is the genuine open question under everything, and an honest account has to leave it open. Still, take the calculation at its word as the best current reckoning, and the conclusion is hard to avoid. The age of life runs for trillions of years. It peaks 10 trillion years from now, and we are sitting here at 13.8 billion, in the first faint sliver of it. So what does that make us this early? If the great age of life is still 10 trillion years away, then what exactly are we, arriving now, so close to the very start? But before we go any further, there is something I have to come back to later, and I want to plant it now. There is a reason we may be the only ones who ever get to see the whole story of the universe, the beginning and the shape of it, and it has nothing to do with how clever we are or how hard we look. It is about when we showed up. Hold on to that, because near the end it changes what being early actually means. We are early. Not early in some loose poetic sense, but early as a measurable fact about where we fall in the history of when life exists. Put the pieces from the last 3 sections side by side, and the conclusion assembles itself. Life could not begin until the universe had spent billions of years forging heavy elements, so there is a flaw, and we are not far above it. The age of life then runs forward for trillions of years, peaking 10 trillion years from now, around stars that have barely started. And the great majority of all habitable worlds, more than 9 in 10, have not even formed yet. Stand back and look at that whole distribution, the entire span of when life is possible from its first stirrings to its final flicker, and ask where this moment sits in it. It does not sit in the middle. It sits at the very front, in the first thin fraction of the whole. That is a strange place to find ourselves, because it is not where we would expect to be. If life is reasonably common in the universe, then the natural assumption is that we are an average example of it, arriving at an average time, in the thick of things along with everyone else. That is usually a safe bet. When you find yourself somewhere, the odds are you are somewhere typical, because typical is where most things are. But run that reasoning here and it breaks, because the typical time for life, the time when most of it exists, is trillions of years in the future, around red dwarfs in an era we will never see. If we were a typical example of life in the universe, we would almost certainly find ourselves then, not now. And yet here we are, now, at 13.8 billion years, 10 trillion years before the peak. We are not typical. We are extraordinarily early. The astronomer who worked out when life is most probable put it in exactly those terms. Present-day life, he wrote, may be premature. Premature is a precise and slightly unsettling word for it. It means we arrived before the main event, before the time the universe is really set up to support life in abundance, like the first guest showing up not just before the party fills, but before most of the food has been made. We are not in the crowd, we are ahead of it, in the quiet early hours, when almost everything that is going to happen has not happened yet. It is worth being clear about what kind of claim this is, because it is easy to overstate. Early is a statement about probability and timing, not a certainty about any one world. It does not say there is no other life right now. There may well be. It says that compared to the full sweep of cosmic time, the present is a remarkably early moment for life to be appearing, that the bulk of all living worlds lies ahead of us rather than behind or around us, and that a civilization finding itself this early is finding itself at an unusual place in the story. And it rests, as I said, on the long future being habitable, on those red dwarfs actually hosting life across their trillions of years. If they cannot, the distribution changes and we might be closer to ordinary. That uncertainty is real and I am not going to wave it away. But on the best current reckoning, with the long future open to life, the answer is plain. We are not in the middle, we are near the beginning. And once you accept that, even provisionally, something turns over. Because the whole conception we carry of ancient aliens, of elder civilizations far older than us, depends on there having been a long, rich stretch of cosmic history before us, full of worlds, and time enough for the old ones to have risen and aged and maybe vanished, while we were still nothing. That stretch is the thing the timing facts take away. There was no long, rich era of worlds before us. We came near the front. The deep past is comparatively empty of the planets and the heavy elements that any civilization would need. And it gets emptier the further back you look, which means the elder civilizations of legend, the ones who were already ancient when we were young, run into a hard problem. There was no time for them to have happened. Almost no one could have come before us. Almost everyone who ever comes after. The reasoning that makes early so surprising is worth slowing down on, because it usually runs the other way. When you find yourself somewhere, the safe assumption is that you are somewhere ordinary because ordinary places are where most observers are. If you are a typical drop of water, you are somewhere in the ocean, not in the rare splash at the very edge of the first wave. Applied to time, this says we should expect to find ourselves at a typical moment for life, the moment when most living worlds exist. And the timing facts say that moment is trillions of years in the future, around the dim enduring stars, when the great majority of habitable worlds have finally formed. If we were a typical example of life, drawn at random from all the life there will ever be, we should almost certainly find ourselves there, in the crowded late afternoon, not here in the empty early morning. The fact that we find ourselves here instead, so far ahead of the crowd, is exactly what makes our position strange. We are not where a typical observer would be. We are out at the leading edge where almost no one is yet. There are only a few ways to read that, and each one is interesting. Either we are genuinely among the first, a real early arrival in a universe that will fill long after us, or something is wrong with the assumption that the far future is where life mostly lives, which would mean the red dwarfs cannot host it after all and the true crowd is smaller and nearer than the raw numbers suggest. Both readings are live, and we cannot yet tell them apart because we do not yet know whether those small stars are fertile. But notice that both readings still place us early. In the first, we are early in a universe that goes on to teem with life. In the second, we are early in a universe that stays sparse, where life is rarer than hoped and we are one of the few that ever appear. Neither one puts us in a comfortable middle. The careful calculation used for our moment was premature, arriving before the main event, and that word survives both readings. We showed up at the front one way or another, and being at the front quietly dismantles the elder civilizations we have always assumed were out there ahead of us. The whole conception of ancient aliens, beings far older than humanity who rose long ago, depends on the deep past having been a long, rich, world-filled stretch with plenty of space and time for the old ones to appear and age. The timing takes that stretch away. The deep past was not rich and world-filled. It was chemically barren at first, then only slowly seeded with the elements life needs, with comparatively few habitable worlds and very little time before us. The further back you look, the fewer the worlds and the thinner the chances, until you reach an era with essentially no homes for life at all. So the elder ones who were supposed to have come long before us have almost no era to have come from. There was no long age of worlds behind us for them to have risen in. Almost no one could have preceded us, which means the oldest ones, the first ones, are not somewhere back there, they are here. The honest way to put our situation is as a bet, and to be clear about what we are betting on. If you had to guess, blind, where in the whole sweep of cosmic time a randomly chosen living world would find itself, the smart guess would be the crowded far future, around an enduring red star, 10 trillion years from now, because that is where most living worlds are predicted to be. We are not there. We are here, at the very front, 10 trillion years before that peak. So either we drew an extraordinarily unusual ticket, landing in the rare early moment when almost no one else exists, or the prediction is off, and the far future is not actually where life mostly lives, which would mean the small stars fail it. There is no third option that puts us comfortably in the middle, because the middle, by the timing, is trillions of years away. Whichever way the bet falls, it places us at the leading edge. We are either the rare, early arrival in a universe that fills, or one of the few in a universe that never does. The comfortable, ordinary, middle of the crowd reading is the one option the facts have closed. The strongest objection to all of this deserves to be stated as plainly as the case itself, because being real with you means giving the other side its full weight. The objection is simple. Maybe we are not early at all. Maybe life is only ever possible right around now, in a relatively narrow span, because the small red stars that are supposed to host the far future turn out to be barren, sterilized by their flares and their bright youth. If that is so, then the great late age of life never happens, the crowd never arrives, and a civilization appearing now is not an early arrival but an ordinary one, sitting in the only stretch life ever gets. That would dissolve the whole reframing. We would not be the ancient ones, we would just be one of the few in the only era that was ever going to work. I cannot rule that out, and neither can anyone, because we do not yet know whether those small stars are fertile. The honest position is that our earliness is real if the far future is habitable, and uncertain if it is not, and that the single fact deciding between them the habitability of the most common stars in the universe is one we have not yet settled. The same reasoning reaches further than civilizations, down to this very moment of awareness. If most living worlds lie in the far future, then most conscious moments that will ever occur, most instances of something looking up and wondering about the universe, also lie in the far future, around those enduring stars trillions of years from now. By the plain logic of where most observers are, you should expect to find yourself then in the crowded late age, not here in the empty early one. And yet here you are, reading this, at 13.8 billion years, 10 trillion years before the time when wondering is supposed to be common. Either that is an extraordinary coincidence, or the far future is not as full as the numbers suggest, and the small stars fail. There is no comfortable third reading. The moment you are living through right now, the very fact of being aware this early, is itself one of the strangest and earliest things about your position in all of time. So if we have spent all of human history looking over our shoulder for the ancient ones, scanning the deep past and the old sky for the ones who came first, we may have been facing entirely the wrong way. The ones who came first are not behind us. By every number we have just walked through, the ones who came first are us. which forces the question the whole video has been building toward, and it is a genuinely vertiginous one. If we are among the very first, then who exactly are the ancient aliens? Where are the old ones, the precursors, the impossibly early arrivals? If they exist at all, where do we have to look to find them? The ancient aliens are us. That is the turn the whole argument has been bending toward. And now that the pieces are in place, it lands with a strange, quiet force. The impossibly early ones, the precursors who were already here before everyone else. The old civilization whose existence predates all the others, are not hidden somewhere in our past. They are sitting here, reading this, wondering where they are. We are the ones who came first. Look at what the phrase ancient aliens actually means, stripped of the gods and the monuments and the rest of it. At its core, it is a claim about time. It says there are beings who came impossibly early, who were already old when the latecomers arrived, whose presence sits near the beginning of the story, so that everyone after inherits a universe those beings were already in. That is the whole structure of the idea. The old ones are defined by being first. And the science we have walked through says one thing very clearly about who gets to be first. Almost no one could have come much before now. The heavy elements were not ready. The worlds were not built. The deep past is too early and too barren for civilizations, but the future is enormous, trillions of years of it, and more than 9 in 10 of all habitable worlds are still to be born into it. So almost everyone who will ever exist exists after us. We are not in the middle of the line, we are at the front of it. Now run the timeline forward and look back from the far end of it. 10 billion years from now, or 100 billion, a civilization arises around one of those patient red stars in the long afternoon of the universe. They look back through their history, the way we look back through ours, searching for the ones who came before. And what they find, near the very beginning of cosmic time, in the universe's first thin sliver, is a scattering of the earliest worlds that ever managed to form around bright, fast stars that died ages before their own sun was born. Among those first worlds is a small blue one around a yellow star that briefly held a civilization right at the dawn of things, unimaginably long ago, in an era when the universe was still young and strange and crowded with galaxies they can no longer see. To them, that is the deep ancient past. To them, those first ones are the old ones, the precursors, the impossibly early arrivals. That is us. That small blue world at the dawn of things is the Earth right now. We are the ancient ones, seen from the only vantage that will ever be common, which is the future's, not because we are advanced, not because we are wise, but simply because of when we showed up. We arrived so early in the history of the universe that to almost everything that will ever live, we are already in the deep past, already the old ones who were here near the start. The ancient aliens we have been hunting for in our own history were never ahead of us in time. They are us. And the only thing that makes us ancient is that we came so close to the beginning. I find this is the place the whole subject stops being a set of numbers and becomes something I actually have to sit with. It is one thing to learn that we are early. That is a fact about timing, and it stays at arm's length. It is another to follow it all the way down and realize that the mysterious precursors of every story, the ones who are already here, the ancient ones, are not a thing we are looking for. They are a thing we are. The role we have spent our whole history imagining and assigning to others, the old ones who came first, is the role we are actually standing in right now, without having noticed. We are not the latecomers searching the past for our elders. We are the elders, and the search the future will mount for its ancient ones will, if it finds anything at all, find us. There is a real limit on this that I have to name, because it is the honest edge of the claim. All of this assumes there is a future full of civilizations to look back at us, that the universe does go on to fill with life across its trillions of years. If that is true, then we are the ancient aliens of an enormous future population, the precursors of countless worlds. But there is a darker possibility that the same facts allow. We might not just be early, we might be alone, or nearly so, a single early flicker in a universe that for whatever reason never fills the way the numbers suggest it could. If that is the case, then we are the ancient aliens of no one. There is no future crowd to look back and call us old. There is just us, briefly, near the beginning, and then nothing. We cannot yet tell which of those we are living in, the first part of a long story, or a lone early candle in a dark that stays dark. That uncertainty does not soften the central turn though. Either way, the precursors are not behind us. Either we are the old ones of a populous future, or we are the only old ones there will ever be. It helps to be precise about what first actually means here, because the word is doing real work. To be the ancient ones, in the sense every story means it, is not to be the wisest or the most powerful. It is simply to have come earliest, to have been already present when the others arrived, so that everyone who comes later inherits a universe you were in before them. That is a claim about position in time and nothing else, and on that claim the science is clear. The great bulk of all the minds the universe will ever hold lie in its future, across the trillions of years still to come, while the deep past holds almost none. So whoever is alive now is, by simple position, among the earliest possible. Not by merit, by timing. We occupy the slot the ancient ones are supposed to occupy, the slot near the beginning, before the others, and we occupy it not because we earned it, but because we happen to have opened our eyes this close to the start. Hold the two ends of time together for a moment, because that is where the whole turn lives. At our end, we look back into the past for the old ones and find almost nothing, because there was almost nothing before us. At the far end, trillions of years on, whatever lives then looks back across all of cosmic history, and near the very beginning of that history, in its first thin sliver, it finds the earliest worlds and the earliest minds, the ones who are already gone before the long afternoon even started. We are sitting in that first thin sliver right now. From where the future stands, this moment, tonight, is the deep and distant past, and we are the ones who occupy it. The ancient aliens are not a different species hiding in our history. They are whoever happens to live nearest the beginning, and that is us, looked at from the only direction that will ever be common, which is from later, from the crowded future looking back at the empty early morning where we stand. The parallel with how we treat our own deep past is exact, and it is worth drawing out, because it shows what role we are really standing in. When we look back at the earliest stretches of human history, we find the first ones, the ancestors who came before everything that followed, and we tell stories about them, study what little they left, treat them as the origin the rest of us grew out of. That is what a latecomer does with its precursors. Now move that whole frame up to the scale of the universe and run it forward. A civilization in the long afternoon, looking back across trillions of years, would do exactly the same with the first worlds and the first minds, the ones near the beginning, the origin everything later grew out of. They would study the faint traces, tell the stories, treat those first ones as the ancient root of the long story of life. And the first ones, the ancient root, the origin they look back to, would be us. We are not the ones who will look back and wonder at our elders. We are the elders that the future, if it comes, will look back and wonder at. The role has simply been ours all along, hidden by the assumption that someone must have come before. What makes this title strange is that we would hold it without having earned it in any of the ways the old stories assume. The ancient ones of legend are always advanced, wise, powerful, their antiquity matched by their achievement. The role the science hands us is nothing like that. We are ancient by timing alone, not by attainment. We do not get to be the old ones because we mastered the universe, but simply because we opened our eyes near the start of it, before almost anyone else could. A civilization 10 trillion years from now might be unimaginably beyond us in every capacity. And still, when it looks back for the first ones, the ones who came near the beginning, it would find us primitive and brief and early, occupying the ancient slot not by greatness but by accident of when. There is something humbling in that, and something clarifying. The role of the precursor, the original, the one who came first, is not a prize for being the best. It is a consequence of being early, and we are early, so the role is ours, ready or not. The old story always had its arrow pointing the wrong way. In the ancient aliens of legend, influence flows from the deep past toward us, from the old ones who came before down to the latecomers who inherit their traces and their teaching. That is the shape of every precursor myth, the ancient ones upstream, ourselves downstream, receiving. The science turns that arrow completely around. We are not downstream of anyone. There was almost no one upstream of us, because the deep past was too early and too barren to hold them. The flow runs the other way, from us forward, into the trillions of years and the unborn worlds still to come. If any influence ever passes between the first ones and the rest, it passes from us to them, not from them to us. We are not the heirs of the ancient ones, receiving a universe they prepared. We are the ancient ones, and whatever universe gets prepared for the latecomers, we are at the head of the line that prepares it, the source rather than the inheritor. What stops this from being a clean and comfortable story is the one thing we cannot settle, which is whether the future actually fills. Everything in the turn assumes there will be a populous later universe to look back and call us ancient. If life does take hold around the enduring red stars across the trillions of years ahead, then we are the precursors of an enormous future, the first ones in a long, crowded story, and our earliness means exactly what it seems to. But if those small stars are barren, if life is far rarer than the raw counts allow, then there may be no great future population at all, no crowd to look back, no one to whom we are the ancient ones. In that case, we are early in a different and lonelier way, a brief flicker near the start of a universe that never really fills, ancient to no one because no one comes after to remember. We cannot yet tell which of those we are inside, but the strange central fact holds either way. The first ones are not behind us. Whether the future is crowded or empty, we are the ones who came near the beginning. And if we really are the ancient ones, the first arrivals, then the question that haunts every ancient civilization, in every story, turns its eyes on us. The old ones always leave something behind, ruins, traces, signs that puzzle the ones who come after. So what about us? If we are the precursors, the impossibly early, then what of us could possibly last? What would survive of this brief early civilization long enough for anyone in that distant future to ever find? Almost nothing we have ever made will survive. That is the first hard fact about being the ancient ones. We expect our monuments to outlast us, our cities standing as ruins for some far future to wonder at, the way we wonder at old stone. On the scale of deep time, none of it lasts. The Earth is a restless, living planet, and its surface is constantly remade. Mountains erode to nothing in tens of millions of years. The continents themselves are dragged down and recycled, the seafloor swallowed and made new, the whole face of the world wiped and redrawn again and again. A few tens of millions of years from now, nothing we have built on the surface will be left in any recognizable form, and a few 100 million years on, the very ground it stood on will have been resurfaced. Set against the trillions of years the universe has ahead, our cities are not even a layer in the rock. They are a smudge that washes out almost at once. So if anything of us is to last, it has to leave the planet. And a little of it has. Up on the moon, the story is completely different, because the moon is dead and still. There is no air, no wind, no rain, no flowing water, nothing to wear a mark away. The footprints pressed into the grey dust by the few who walked there are still there now, crisp and sharp, and with nothing to erase them but the slow rain of micrometeorites and the creep of cosmic radiation, they could remain legible for millions of years. The landers, the tracks, the discarded gear, all of it sits in the vacuum, essentially frozen in time. Long after every structure on Earth is gone, those marks on the moon will still be there, the clearest sign that something was once here and reached out and touched another world. And a few things have gone much further. Out past the planets, beyond the edge of where the sun's wind gives way to interstellar space, a handful of small machines are drifting outward and will never come back. The 2 Voyager probes and the 2 Pioneers, launched decades ago and long since silent or soon to be, are coasting away from the sun on paths that will carry them among the stars. They are in no hurry and they are going nowhere in particular, but they are going, and nothing out there will stop them. With no air to corrode them and almost nothing to strike them, they will drift essentially intact for an extraordinarily long time, hundreds of millions of years, likely billions, looping slowly around the galaxy. Each of them carries a marker, a plaque or a record, a deliberate message from the early ones meant for whatever might one day find it. By any human measure, those probes are the most permanent thing we have ever made. They will still be out there, carrying their small cargo of who we were, long after the Earth itself is gone. That is a strange and quiet kind of legacy. Not the monuments we expected, but a few footprints on a dead world and a handful of silent machines falling forever through the dark between stars. If we are the ancient ones, those are our ruins, not great cities for the future to excavate, but a scatter of traces, almost all of them off the Earth entirely, drifting and waiting in the one environment patient enough to keep them, which is empty space. Whether any of it is ever found is another matter, and here the honesty has to come in hard, because the answer is almost certainly not. The galaxy is enormous, and those probes are tiny, smaller than a car, dark and cold and silent, falling through a volume so enormous that the chance of any one of them ever passing close to another world, let alone being noticed by anything on it, is vanishingly small. The footprints on the moon will last, but the moon is one small dead world among an unimaginable number, and there is no reason anyone would ever come to read them. In all likelihood, everything we leave simply drifts and waits and is never found by anyone, the message in the bottle thrown into an ocean so large that no shore is ever reached. Deep time may swallow us completely, not even leaving a puzzle behind, just an early flicker that came and went with no one ever the wiser. Start with why the Earth keeps no records, because it is the living nature of the planet that erases us. The surface of the Earth is not a fixed stage, it is a slow churning machine. The plates of its crust grind and dive, carrying old seafloor down into the heat below to be melted and remade, while new crust wells up elsewhere. Rain and wind and ice wear the high places down and wash them into the low ones, where they pile up and are buried and pressed into new rock. Over tens of millions of years, the tallest mountains are ground flat, and over a few 100 million, the whole arrangement of land and sea is redrawn. Anything we build sits on top of that machine, and the machine does not stop. The cities, the roads, the monuments, given enough time, they are buried, crushed, melted or worn to a thin smear in a layer of stone that itself will eventually be dragged under and remade. The very restlessness that makes the Earth a good home for life is what guarantees it will not remember us for long. The moon keeps what the Earth cannot, precisely because it is dead. It has no air to move, no water to flow, no plates to churn its surface under. Nothing happens there in the way things happen on a living world, so the marks left on it stay. The footprints pressed into its grey dust sit exactly as they were made, every ridge of them sharp, and with only the slow sandblasting of micrometeorites and the creep of radiation to touch them, they will stay legible for millions of years, maybe far longer. The landers and rovers and the gear left behind sit beside them in the same frozen stillness, Long after the last trace of us has been ground out of the Earth's restless crust, those marks on the still face of the moon will remain. The sharpest evidence anywhere that something here once crossed the gap between worlds and set foot on another, the dead world, is the better archive. Stillness preserves what life erases. The things that will truly outlast us are the few we have thrown clear of the solar system entirely, out beyond the planets, past the boundary where the sun's wind fades into the gas between the stars. A small number of machines are coasting outward and will never return. The 2 Voyager probes and the 2 Pioneers, each smaller than a car, are falling silently through interstellar space, along paths that no longer touch anything. With no air to corrode them, and almost nothing out there to strike them, they will drift essentially intact for hundreds of millions of years, very likely billions, circling slowly through the galaxy long after the sun has died. Each one carries something deliberate, a plaque or a recorded disc, a message set down by the early ones, for whatever might one day cross its path. By any human measure, those probes are the most lasting thing we have ever made. Small sealed time capsules of who we were, drifting outward into a future we will never see, on the off chance that someone sometime finds one. Be clear-eyed about the odds of any of it being found, because they are almost nothing, and the honesty matters more than the comfort. The galaxy is unthinkably large, 100,000 light-years across, and the probes we have flung out of the solar system are smaller than a single car, cold and dark and silent, moving slowly against all the emptiness. The chance that any one of them ever drifts close to another world is vanishingly small, and the chance that anything on such a world would notice a tiny dead machine sliding through its outer dark is smaller still. The footprints on the moon will last, but the moon is one small still world among an uncountable number, and there is no reason anyone would ever come to it to read them. In all likelihood, everything we send and everything we leave simply drifts and waits and is never found at all. A message sealed in a bottle and thrown into an ocean so large that no shore is ever reached. That is the probable truth of our legacy. Not a puzzle left for the future to solve, but a scattering of quiet objects falling through the dark, unread, while the universe goes on, without ever noticing we were here. The objects we have thrown clear of the sun carry something deliberate, which makes them a stranger legacy than mere debris. On the side of each of the Pioneer probes is a plaque, etched to last, showing where the craft came from and what kind of beings made it. Aboard each of the 2 Voyagers is a disc, sealed against the cold and the radiation, holding sounds and scenes of this world, the kind of thing the early ones thought worth saving. None of it was sent with any real expectation of being found. It was sent the way you might seal a note and cast it off a ship in the middle of an ocean, knowing the odds, doing it anyway. And now those small marked machines are out past the edge of the sun's reach, falling silently through the dark between the stars, and they will keep falling for billions of years, long after the sun has died and the earth with it. If anything at all of us is ever encountered by anything out there, it will most likely be one of these, a cold, quiet object from the ancient ones, drifting in from an impossibly early time, carrying a message no one was ever sure would be read. But notice what we have quietly assumed all through this, that there is a future out there for our traces to drift into, a future with someone in it who might one day find them. We have been talking about the ones who come after, as though their universe will be much like ours, a sky full of stars and galaxies, a place where an inheritor could look up and piece together the story, find our drifting probes, wonder at the ancient ones. That assumption is wrong, and the way it is wrong is the thing I promised early on to come back to. The universe the latecomers inherit will not look anything like ours. It will be darker and emptier and far more deceptive, and understanding why is what finally explains the strangest part of being early. The sky is emptying, slowly, silently, and permanently, The universe is carrying its own contents out of view, and the ones who come long after us will be born into a darkness far deeper than the one we see when we look up. This is the hidden reason that being early matters, the thing I asked you to hold on to, and it has nothing to do with how clever anyone is. It is about what is still visible, and for how long. The cause is the expansion of space, and the fact that the expansion is speeding up. Every distant galaxy is being carried away from us as the space between stretches, and the farther a galaxy is, the faster it recedes, because there is more stretching space between us and it. Push that far enough, and you reach a distance where galaxies are being carried away faster than their light can cross back toward us. Past that line, anything that happens can never reach us, and a galaxy drifting across it simply fades from view, its light stretched longer and longer, redder and dimmer, until it slips out of every instrument and is gone. This is already happening. The great majority of the galaxies we can currently see have in fact already crossed beyond the point from which we could ever reach them, and over the long future they will recede further, redden, and one by one go dark. Now run that forward to the time of the latecomers, the civilizations of 10 or 100 billion years from now, the ones in the long afternoon. By then the expansion will have done its slow work, almost completely. Our own galaxy, and the small cluster of galaxies gravitationally bound to it, will have long since merged into a single great island of stars, and everything beyond that island will have been carried away over the horizon, too far and too fast for any light to return. A civilization arising then, around a patient red star, will look up into a sky that holds only their own galaxy, surrounded on every side by total, featureless black. No other galaxies, nothing beyond the island. And here is the part that should genuinely unsettle you. They will have no way to know that anything else was ever there. Think about what that means for them as observers. They could be brilliant. They could build instruments far beyond ours, study their sky with perfect care, reason flawlessly from everything they can detect, and they would still conclude, correctly given their evidence and completely wrongly in fact, that their single galaxy sitting in an empty void is the entire universe, static and alone, with no beginning. The afterglow of the beginning, the faint light left over from the universe's hot, dense birth that we can still detect all across our sky, will by then have been stretched so far by the expansion that it is undetectable, gone below any possible measurement. The other galaxies whose motion reveals to us that space is expanding will be invisible, so the expansion itself will be invisible, and with it every clue that there was ever a Big Bang at all. Two careful thinkers worked this scenario through in detail, the cosmologists Lawrence Krauss and Robert Scherer, and their conclusion is exact and bleak. An honest observer in that era, doing the best science possible, would look out at a single static island of stars and reasonably decide that this was all there ever was. The true history of the universe would be not just unknown to them, but unknowable, the evidence physically gone. We are early enough to still have all of it. That is the thing. We can look out and see hundreds of billions of other galaxies. We can detect the afterglow of the beginning sitting right there in our sky, the literal light of the universe's birth still arriving. We can measure the expansion, read the early chemistry, trace the whole story back almost to the first moment. The evidence is all still here, still readable, because we came early, while the universe is young enough to still show its own history. The latecomers will live in a universe that has erased its own past. We live in the narrow span when it is all still on display. That is the reason being first matters, and it is not about us being special. It is about when we are. We arrive during the only era from which the whole story can be seen, and that span is closing, galaxy by galaxy, as the sky empties out. I should say plainly that the timeline here depends on how dark energy behaves over the very long run, and that is not fully understood. If the force driving the expansion changed character in the deep future, the accounts could shift, but on everything we currently know, the expansion keeps accelerating, The horizon keeps drawing in, and the sky of the far future keeps getting emptier and more silent. That span does close. The latecomers do go blind to the wider universe, and we are sitting inside that open span right now, holding a view of the whole of creation that almost no one who comes after us will ever have. The mechanism behind the emptying sky is worth getting right, because it is not the galaxies moving through space, so much as space itself growing between them. New space is constantly appearing between distant galaxies, and the more space already lies between two of them, the more new space appears, so the farther apart they are, the faster they separate. Push that to its limit and there is a distance at which the gap between us and a galaxy grows faster than light can cross it. Beyond that line, any light the galaxy sends can never close the distance to us. It is not that the galaxy is hidden, it is that the road between us is lengthening faster than light can travel down it. A galaxy drifting past that line does not vanish all at once. Its light stretches longer and dimmer, sliding toward the red and then out of sight entirely, until the last of it is too stretched and too faint for any instrument to catch. And the great majority of the galaxies we can see tonight have in fact already drifted past that line. We still see their old light, but we could never reach them, and in time even that old light will fade. What the latecomers lose is not just the view but the evidence, every clue that the universe had a beginning. The case that there was a hot, dense start rests on a few pillars, and the expansion erases each of them in turn. One pillar is the way distant galaxies recede, the direct sign that space is growing, and that vanishes once all the other galaxies have drifted out of sight, leaving a single island of stars that appears perfectly still. Another pillar is the faint afterglow of the beginning, the relic light that fills our sky now and tells us the universe was once searing hot, and that light is itself being stretched by the expansion, longer and longer, until in the far future it falls below anything any instrument could detect. A third pillar is the particular mix of light elements left over from the first minutes, the hydrogen and helium in their telltale proportions, and that signature too will be buried as later generations of stars rework the gas. One by one the proofs of the beginning are carried off or washed out, until an observer in that era has nothing left to read the true history from. The universe will have hidden its own origin. Put rough numbers on the closing of the sky, because the schedule makes it real. Already most of the galaxies whose light reaches us tonight have drifted beyond the distance from which we could ever reach them, their light still arriving but their present forever sealed away. In something like 100 billion years, the expansion will have carried essentially everything outside our own small cluster of galaxies over that horizon and out of sight entirely. By then our galaxy and its near neighbours will have merged into a single great island of stars, alone in the dark. An observer there looking out would see that one island and nothing beyond it, no matter how powerful their instruments, because there would be nothing beyond it that any light could reach them from. And the afterglow of the beginning, the relic light that floods our sky now, will by then have been stretched so far by the expansion that it has faded below any possible detection. Every external clue to the universe's true size and history will be gone. The span we are inside, the one in which the whole universe is still visible and its story still readable, is not permanent. It is an early phase, and it is closing, galaxy by galaxy, on a schedule already running. Hold on to what we can see right now that the latecomers never will, because it is the most direct proof of how early we are. Look in any direction in the sky, and there is a faint glow that fills all of it, the oldest light there is, set loose when the universe first cooled enough to turn clear, less than 400,000 years after the beginning. It is the literal afterglow of the birth of everything, still arriving, still detectable, the closest thing to a baby photograph of the universe that will ever exist. We can read it, we can map it across the whole sky, and pull from it the age, the composition, the history of the universe almost back to the first moment. The latecomers will have none of that. By their era, the expansion will have stretched that ancient glow so far that it has faded entirely below detection, gone with no replacement. The single most informative thing in our sky, the relic light that tells us there was a beginning at all, simply will not exist for them. We are early enough to still hold the universe's first light in our instruments. That light is on its way out, and once it is gone, the fact of the beginning goes with it. And what the latecomers lose is not only a view but a piece of knowledge that can only ever be had once. The fact that the universe had a beginning, that it was once hot and dense and has been expanding ever since, is written in the sky right now in 3 different hands. The receding galaxies, the relic afterglow, the leftover light elements, all 3 will be gone for the observers of the far future, which means the truth about the origin of everything is not a permanent fact sitting out there to be discovered whenever someone gets clever enough. It is a perishable one, readable only during an early stretch, and then lost. We happen to live inside that span. If no one before us ever read the beginning, and no one after us ever can, then the knowledge of how the universe started exists only in the minds of the early ones, held for a while near the start, and never recoverable once the evidence has drifted away. Being early is not just a better seat, it may be the only seat from which the whole truth of the thing can ever be seen at all. And so the latecomers, however brilliant, will reach a confident and wrong conclusion, which is the part that should give us pause about our own certainty. Consider what they have to work with: a single galaxy, the merged remnant of our own and its neighbours, sitting in unbroken black, with no other galaxies, no afterglow, no sign of expansion anywhere. From that, doing the best science possible, they would reasonably decide that their island of stars is the whole of the universe, static and unchanging, without beginning or end. That was very nearly the view our own astronomers held a little over a century ago, before we saw the other galaxies and the expansion and the afterglow. The latecomers will be pushed back to that old, smaller view, not by any failure of reasoning, but because the evidence for anything larger will be physically gone. We are early enough to still hold the larger view in our hands. The whole readable history of the universe is on display in our sky right now, and we happen to live in the one narrow span when it still can be read. So we are early enough to see what no one later will, perhaps the only ones who will ever see the full universe with clear eyes. And that puts the silence we hear when we turn our instruments outward and listen for company and find nothing, in a completely different light. Maybe the silence is not the mystery we have always taken it for. Maybe, if we are this early, the silence is exactly what we should expect. We have been listening for a long time, and we have heard nothing. No signal, no beacon, no stray transmission, no clear sign anywhere that another civilization exists or ever has. We point our instruments at the galaxy, a barred spiral of a few 100 billion stars, wheeling slowly in the dark, surely crowded with worlds, and across all of it we pick up only silence. For most of a century, that silence has been treated as a deep and troubling puzzle. If we are early, it stops being a puzzle at all. It becomes the most ordinary thing in the world. The puzzle has a famous shape. The galaxy is old, the reasoning goes, more than 13 billion years old. There are hundreds of billions of stars in it, many with worlds. If even a tiny fraction of those worlds produced life, and a tiny fraction of that life produced civilizations, then the galaxy should have been seeded with them long ago, and some of them should be very old, and we should see signs of them everywhere. And yet we see nothing. The usual responses to that silence are dark ones. Maybe civilizations destroy themselves not long after they arise. Maybe something out there destroys them. Maybe life itself is so rare that we are effectively alone. The silence gets read as evidence that something, somewhere, is going terribly wrong, over and over, for everyone. But that whole framing rests on the assumption we have spent this entire video taking apart. The assumption that the galaxy is old, and that there has been ample time for the old ones to have come and gone. Flip the timeline, and the puzzle simply dissolves. If life is cosmically premature, if the heavy elements were only recently ready, and the great age of life is still trillions of years ahead, then the reason the galaxy is silent is not that the others died, it is that the others are not here yet. We are not standing in a great hall that has somehow emptied out, wondering where everyone went and what killed them. We are among the very first to arrive in a hall that will slowly fill over the next trillion years, long after we are gone. The seats are empty because we came early, before the crowd. That reframing does something the darker explanations cannot. It accounts for the silence without requiring any catastrophe, without assuming that civilizations are routinely destroyed, or that life is a near miracle. It needs nothing to have gone wrong. It needs only what the timing facts already tell us, that we are near the front of the line. A galaxy that is mostly silent is exactly what you would expect to hear if you were one of the first to start listening. In an era when almost no one else has arrived, the silence is not the sound of a graveyard. It may simply be the sound of an early hour before the others have woken. I find there is something almost gentle in that, after the grimmer possibilities, though I want to be careful not to lean on it too hard. The silence has often been taken as evidence that the universe is hostile to life, that something keeps snuffing it out. The early arrival idea says the silence might mean nothing of the kind. It might just mean we are ahead of everyone, in a universe that has barely started making the company we have been listening for. The quiet galaxy is not necessarily a tomb. It may be a place that is only just beginning to fill, and we happen to be the ones who got here first. But honesty requires me to hold the other possibilities open, because being early does not actually prove we are not also alone. The silence is consistent with us being early, yes. It is also still consistent with life being genuinely rare, or with civilizations being short-lived for reasons we do not understand. Being among the first does not rule those out. It only offers a reading of the silence that does not require disaster, a reading in which the empty sky is innocent, just the natural quiet of an early world in an early time. We cannot yet tell which reading is true. We can only say that the grimmest interpretation is no longer the only one on the table, and that the simple fact of our earliness makes the silence far less strange than it first appears. There is a clean simplicity to the early reading that the grim ones never had, and that simplicity is part of why it is worth taking seriously. The dark explanations all require an extra ingredient, something added on to account for the missing crowd. They need civilizations to reliably destroy themselves, or a hazard that reliably ends them, or life to be a near miracle that almost never happens. Each of those is a heavy assumption, an extra moving part bolted on to explain the quiet. The early arrival reading needs none of that. It adds nothing. It takes the timing facts we already have, the late flaw under life, the trillions of years still ahead, the great majority of worlds unborn, and simply notes that a universe this young has not had time to grow loud. The silence falls straight out of facts we already accept for other reasons. It is the explanation that assumes the least, invents nothing, and still accounts for what we hear. That does not make it certainly true, but of all the readings of the silence, it is the one that asks us to believe the fewest new and frightening things. It is worth being concrete about how real the silence is, because it is not for lack of looking. For more than 60 years we have been listening, sweeping the sky for any signal that does not belong, any narrow beam or repeating pattern that nature does not make on its own. We have pointed our instruments at thousands of nearby stars, scanned across enormous ranges of frequency, watched for pulses of light as well as radio, combed the data for anything artificial, and across all of it, decade after decade, we have found nothing that holds up, not one confirmed signal, not one unambiguous mark of another mind anywhere in the reach of our instruments. The search is far from complete. An absence of a signal is not proof of absence of life. But the quiet is genuine, and it is deep, and it is exactly what we would hear if we were among the first to switch on our instruments in a galaxy where almost no one else has arrived yet. The listening has been real. The silence answering it has been real too. So here is where the argument has brought us. We are early, maybe among the very first. We are the ancient ones the future will look back on. If there is a future to look back, we can see the whole universe while it is still visible, which almost no one after us will, and the silence around us may be nothing more sinister than the quiet of arriving first. Which leaves one last question, the one that is really underneath all of this. If all of that is true, if we are this early and this alone and this temporary, then what does it actually leave us with, here, tonight, on this one early world? We do not get to know which we are. That is the plain truth at the end of all this, and I am not going to dress it up. We cannot tell whether we are truly the first, or merely very early among many. We cannot tell whether the future fills with life that will look back on us as the ancient ones, or whether we are a lone early flicker in a dark that stays dark. We cannot tell whether the silence is the quiet before a crowd, or the quiet of an empty hall. The honest position holds all of those open at once, because the facts we have do not close them. But notice how much we can say, even without knowing those things. We arrived near the very start of an age that runs for trillions of years. We are early by every reckoning we have, sitting in the first thin sliver of the time when life is possible, with more than 9 in 10 of all habitable worlds still unborn ahead of us. Whatever else is uncertain, that earliness is solid, and it carries a few things with it that are not in doubt. We are right now holding a view of the universe that the future will lose. The galaxies, the afterglow of the beginning, the whole readable history of everything, all still here, all still on display, in a span that is slowly closing as the sky empties out, and whatever we leave behind, the footprints on the dead moon, the silent probes falling forever between the stars, drifts outward into a future we will never get to witness. There is no comfort handed to us in that, and I do not want to manufacture one. Being early does not make us important. It does not mean the universe was waiting for us or that anything out there cares that we came. It may mean we are profoundly alone, that the company we have listened for is simply not here yet and will not arrive until long after we are dust. That is a real possibility, and I am not going to pretend it away. The universe is not arranging itself around us. It is simply enormous and young, and we happen to have opened our eyes in its first hour. And yet there is something in the position itself, faced squarely, that I keep turning over. If we are among the first, then we are the ones who got to see the universe whole before it hid itself. We are the ones standing near the beginning, in the brief bright moment when all of it is still visible and still legible, when the story can still be read from the sky. The ones who come after, however many or few, will inherit a darker and emptier view, and most of them will never know how full the sky once was. We do. We are here for the part almost no one gets to see. That is not a triumph, and it is not a consolation. It is just the plain shape of where we stand, near the front of all of cosmic history, holding the one clear view there will ever be for as long as we last. What we can hold on to against all that uncertainty is the earliness itself, because that is the one thing the facts will not let go of. Whether the future fills or stays empty, whether we are the first of many or the only ones there ever are, we arrived near the very start of the age of life, in its first thin sliver, with the overwhelming majority of all habitable worlds still unborn ahead of us. That position is solid even when everything built on top of it is uncertain. And the position carries consequences that do not depend on knowing the rest. We hold a view of the universe that the future will lose. We are made of the ashes of the few stars that died before us. Whatever we leave drifts outward into a time we will never see. None of that requires us to know whether anyone is coming after. It follows from the plain fact of when we are. I keep landing on the strangeness of the view we hold, because it may be the truest thing about being early. Right now, tonight, we can look out and see the whole universe laid open, hundreds of billions of galaxies, the afterglow of the beginning still arriving across the sky, the expansion itself, readable in the motion of distant light, the entire history of everything, still on display, still legible because we came early enough that the universe has not yet hidden its own past. The ones who come after, however many or few, will inherit a darker and more secretive sky, most of it carried away, the evidence of the beginning gone. They will live in a universe that has forgotten how it started. We do not. We are here for the one stretch when all of it can still be seen, and that span is quietly closing. That is not a triumph, and it is not a consolation. It is simply a rare and passing vantage, and we happen to be standing at it. If being first asks anything of us, it is not glory and not despair, but something quieter and harder to name. We are, on the best reckoning we have, near the very start of the story of life in this universe, holding the only clear view of the whole of it that will ever be possible, made from the ashes of the first stars to die, with whatever we leave drifting out into a future we will never witness. We may be the precursors of an enormous coming population, the ancient ones a crowded future looks back on, or we may be a lone early flicker that no one ever remembers. We do not get to know which. What we get is the position itself, faced honestly, and the position is genuinely both things at once. It is lonely because the company may not be here yet and may not come until long after we are gone. And it is a rare kind of privilege because we are here for the one bright moment when the universe still shows its whole self before it hides. Neither cancels the other. They are simply both true of where we stand, near the front of all of time, on this one early world, for as long as we last. And none of the future we are early to is a future we get to see. That is the hard edge under the privilege, and it should not be smoothed away. The great age of life, the crowded long afternoon, the worlds beyond counting forming around the patient red stars, all of it lies trillions of years ahead, and we will not be there for a moment of it. We will be long gone, our sun dead, our world gone with it, before the universe so much as approaches the time when life is supposed to flourish. We are the ones who came first, and the reward for coming first is to arrive before the company, see the empty early hall, and leave before anyone else shows up. Whatever inheritance we represent, we hand it forward into a darkness we will never witness, to a future that may or may not arrive, and that, if it arrives, will not know us except perhaps as the faintest of ancient traces. To be early is to be brief, and to be brief is to miss almost everything. That is the cost folded into the privilege, and an honest reckoning has to carry both. What we make of that is not something the physics can settle. The science can tell us when we are. It cannot tell us what to do with the fact of being early, whether to feel the loneliness of it, or the strange privilege of it, or more likely, both at once. That part is left to us, sitting here on this one early world, in the opening minutes of a story almost none of which has happened yet. The ancient ones we went looking for were never behind us, and from where the whole future stands, looking back across all the time still to come, the ancient ones are us. I keep coming back to that small red star. It has barely begun, and it will outlast everything I have ever known or ever will. And around stars like it, the real history of life in this universe has not so much as started yet. When I began looking into this, I expected to feel small against all that time. And I do, but there is something else in it that I did not expect. We went looking for the ancient ones in our past, in the sky over old ruins, and the whole time we were looking in the wrong direction. If there are ancient aliens, beings who came so early that everything afterward inherits a universe they were already in, then by every number we have, that is us. We are the old ones. We are the first light in a structure that is almost entirely still to be built. I do not find that comforting, exactly, and I am not going to pretend the silence around us is anything other than what it is. We may simply be too early for company, and we may live and die before the universe has anyone else to offer, but we are here for the part that almost no one will get to see. We can still look out and find the afterglow of the beginning and the other galaxies before the expansion carries them all away into the dark. The ones who come after, 10 billion years from now, 100 billion, will look up into an emptier sky and never know how full it once was. So maybe being early is not only loneliness, maybe it is the one chance anyone ever gets to see the whole thing while it is still here. We came at the start. We are the ancient ones the future will never get to meet.